Okay, for this section of the website, the GP education part, the first section I'm going to talk about is skin anatomy and biology. So, the layers of importance in that we deal with in dermatology are the layers of the skin, the epidermis and the dermis. We also deal with some conditions that affect the subcutaneous tissue. So, firstly, I'm going to talk about the epidermis, and the basement membrane basically separates the epidermis from the dermis. And the predominant cell in the epidermis is the keratinocyte. And the keratinocyte starts off in the basal layer. And the basal layer is the deepest layer, and its cells continuously divide. So basically, they're stem cells, and they form keratinocytes that make their way up to the surface throughout their life cycle and then become continuously shed. And as the keratinocyte makes its way up from the basal layer towards the surface, it changes its composition and tends to get flatter. So as mentioned, the basal cell is the deepest layer. Its cells continuously divide and they form keratinocytes. The stratum spinosum is the layer on top of this, and again it contains keratinocytes that are making their way through to the surface. Above the spinous layer is the thin granular layer, or stratum granulosum. This is a blue layer, and it contains these cells within this contain keratohyalin granules, and they contain a very important protein called filaggrin, and this is important in eczema and also other skin conditions. And then above the granular layer is the stratum corneum, or it's also called the horny layer, and this is the outermost layer. And it contains corneocytes, and these are basically keratinocytes that have completed their differentiation program and they've lost their organelles and cytoplasm and nucleus. And these cells are constantly shed from the epidermis. So the stratum corneum is very important. It provides about 90% of the barrier function of the skin. And a good way to think of the stratum cornea is of bricks and mortar. Um, sorry. So the brick consists of corneocytes, or these dead cells, and the mortar consists of a variety of lipids and other substances which surround the corneocytes, and these are also important in barrier function. And this can be demonstrated from this picture here of basically a brick wall acting as barrier. So the thickness of the epidermis can vary, so it's very thin in the eyelids and it's quite thick in the palms and soles, and this will influence the type of treatments you may apply. So you might only use very weak steroid creams in the eyelids, whereas you might be able to use stronger steroids in the palms and soles. Now, the keratinocytes are held together by proteins, and these proteins are called desmosomes. And it's basically a family of different proteins, and they can be broken up into subtypes of desmoglions, which are numbered. And if certain desmoglions are missing, so they could be missing at birth, or if they're attacked, so you could make an autoimmune attack against it, you tend to get blistering. And if it's in the epidermis, which it is here, you'd often get these very shallow blisters. And oftentimes when they present to the doctor, they'll just be seen as erosions, as the blisters will have already burst. Now, underneath the epidermis and connecting the basal keratinocytes, so basically the bottom keratinocytes to the basement membrane, are the hemidesmosome proteins. And again, these are a family of proteins that basically hold the epidermis to the dermis. And the basement membrane is a very complicated structure, and that's what I've been used this schematic to try to show how complicated it can be. And again, if any of these proteins are missing or if any of them are attacked, they can cause blistering disorders. And as the area of attack or the protein is not functioning deeper down, the blisters down here tend to be much more tense, and they don't form the erosions like in blistering disorders higher up. Now, in general, if you can see here, you can see the lamina lucida. If the blistering or if the split occurs here or above it, generally you don't tend to get scarring. However, if the blistering occurs below it, you can get scarring. And I will do a section later about the different blistering disorders, and I'll go through this again in that section. So there are, apart from the keratinocytes, there are other important cells in the epidermis. So the Langerhans cells are immune cells. They're derived from the bone marrow. They're the members of the monocyte macrophage series of cells. And these cells are basically antigen presenting cells. So any antigens that may penetrate the skin, these cells can envelope them and they take these to the local lymph nodes where an immune response can be instigated. The melanocytes, which of course are very important, are also found in the epidermis and they're derived from the embryonic neural crest. And they tend to be found along the basal layer of the epidermis. And in normal skin, these are found in about a 1 to 10 ratio to keratinocytes along the basal layer. And they've got these little dendritic processes which extend uh, up and connect to other keratinocytes, and they basically provide pigment to the overlying keratinocytes, which will protect against UV damage. These melanocytes can cluster along the basal layer, and when they do, they can form nests. And if these are all benign looking cells in an ordered way, it's a benign nevi. However, if these cells become atypical, basically becoming malignant, they can form a melanoma. And another cell, which is a rare cell in the epidermis, is the Merkel cell. Again, this is of neural crest origin, and it plays a part in sensation at the nerve endings. So it's basically a nerve cell. And if this becomes malignant, you get a thing called a Merkel cell carcinoma, and this is a very poor prognosis. So now moving on to the dermis. So dermis basically is the connective tissue of the dermis consists of collagen and elastic fibers, which are embedded within a thing called ground substance. And these collagen and elastic fibers are formed by fibroblasts. And the upper part of the dermis is called the papillary dermis, and the lower part of the dermis is called the reticular dermis. And unfortunately, I actually don't have any good images of that, which I will get at a later stage. Now, the ground substance, which is between the collagen and the elastin fibers, are made up of things called glycosaminoglycans, and these can be called hyaluronic acid and dermatan sulfate. And actually, hyaluronic acid is often the material used in fillers in cosmetic dermatology to, make things look fuller. So, for pumping up lips or and things like that. Now, within the dermis, there are a lot of appendageal structures, and I can basically, there's an image of these right here. So the hair follicle is often found in the dermis and it can extend down to the subcutis, and it's got a erector pili muscle connected, which this basically, when it contracts, makes the hair stand up. Connected and at the upper part of the dermis are the sebaceous glands. And these basically release sebum into the hair follicles. And obviously, these are very important in things like acne. The apocrine sweat glands, which are not pictured here, are sweat glands that also can open up into the hair follicle. And they tend to be larger than the eccrine gland, which is pictured here. And they're only found in certain situations of the body, so such as the axilla, the areola, in the genital areas, and in the perianal areas. And then the equine sweat glands, which are found in most locations in the body, open up onto the skin surface. So you get this coiled area, which then opens up into a ductal area, which then extends up through the epidermis. Here is just an image of kind of the circulation of the dermis, and you basically get these down in the subcutaneous area. You get arterial supply and venous drainage, and then these connect up into a deep dermal plexus and a superficial dermal plexus. You also get the blood vessels concentrating around the appendageal structures, such as the hair follicle, the sebaceous glands, and the sweat glands. And then you also get these little papillary loops, which extend from the superficial dermal plexus up towards the epidermis. Of note, the epidermis actually doesn't have blood vessels within it. Now, just to finish up, so the skin can encounter a host of toxins and organisms and physical stresses. So, as well as functioning as a physical barrier, it can also be considered as an active immune organ. So, immunological cells in the skin can play a very large part in many skin diseases. And different immunological cells that can be found in the dermis include neutrophils, eosinophils, lymphocytes, B and T lymphocytes, plasma cells, monocytes, macrophages, and mast cells. And we'll go into different conditions that can involve a predominance of these cells as we go on. Thank you very much.